everybody, this is the notes for 6.5. This is difference of squares and perfect square trinomials. So these are both really important cases of trinomials we're going to factor that it's going to help you a ton if you can just recognize them. Click forward. There we go. So the factored form of a difference of squares looks like this. It's a squared minus b squared, and it factors into a plus b, a minus b. Like there is, the thing about this is you really have to be able to recognize it and pick it out and go like, oh, those are perfect squares. So if you do not know the perfect squares off the top of your head, it would be handy for you to make a list somewhere, like 1, 4, 9, 16, 25, 36, and so on. 1, that's the perfect square of 2, perfect square of 3, 4, 5, 6, and make this list so that you have those numbers like fresh in your memory so that you can recall them when they show up and go like, oh, that's a perfect square. So for example, these are all differences of squares. Notice that it is a difference. It is not a sum. It is never a sum. So when I look at A, what I see is y squared is a perfect square. Any even power is a perfect square because it can be divided in 2. And 25 is a perfect square. It's being subtracted, so it is a difference of squares. So when I see that, I'm going to do y plus 5, the bases of each square. Y times y is y squared, and 5 times 5 is 25. Y minus 5, y plus 5. And if I FOIL this out, I am going to get y squared minus 25. Look at the second one. Think about the squares. 49 is a perfect square. S squared is a perfect square. 4 is a perfect square. So is t to the 4th. Any even power is a perfect square. So I'm going to basically figure out what the squares are. So 7 is the root of 49. S is just the root of s squared. Minus 2 times 2 gets me 4, so that's 2. And t squared times t squared gets me t to the 4th. So it's going to be 7s minus 2t, and then 7s plus 2t squared. That's all there is to it. You look at the second one, the last one, it's not a perfect square, right? But there are common terms. So I'm going to take out the common terms first. It's 2z. And once I do, I get 9w squared minus 1. That is a perfect square. It's a difference of squares because 9 is a perfect square, w squared is a perfect square, and 1 is a perfect square. 1 times 1 is 1. So then I can factor this. I'm going to leave the 2z out front. I'm not going to lose track of it. 3w minus 1, 3w plus 1. And if you don't believe me, FOIL, check. If you're not sure at some point, check. The second kind of thing that you're going to see show up is the sum of squares. If A and B are no common factors, they're sum of squares. Sum of squares is not factorable over real numbers. You cannot do anything with this. It is prime every time. So if I have 4x squared minus 9, that's a difference of squares that I can factor. 4x squared plus 9 is prime. The plus sign makes all the difference, okay? Gotta notice it though. All right, so we're gonna factor these if possible. So the first one is p squared minus 9. P squared is a square, 9 is a square, it's being subtracted. So it is possible. It's gonna be p minus 3, p plus 3. P squared plus 9 is not, it is prime because of the plus sign. T squared minus 144 is factorable, t minus 12, t plus 12. T squared plus 141 is not, it's prime, once again, because of that plus sign. All right, let's try something else. The second, we're not on to the second kind of thing yet. So this is another kind of perfect square. Remember, perfect squares, as long as it's an even power, it's a perfect square. It can be divided in two. So in this case, but what's going to happen occasionally is you'll have an extra step. So let's watch. So I'm going to have w squared minus 9, w squared plus 9. And the trick here is that this w squared minus 9 is also a difference of squares. So that needs to be factored one step more, because I can do w minus 3, w plus 3, and then w squared plus 9 is just a prime, so it stays. Okay, so in these cases where you have a higher exponent, often there is extra work to do. Same thing here in the next one you try. So I get y squared minus 1, y squared plus 1, and then this y squared minus 1 is still factorable. Y minus 1, y plus 1, because that's also a difference of squares, y squared plus 1. All right. These two look crazy, right? But they're not. Remember, when you see 4 terms, your brain should go, oh, factor by grouping. So I'm going to group. So the first pair, I'm going to take y squared. I'm going to get y minus 5. Now the second group, I'm going to take a negative 4 and get y minus 5. Remember, I took a negative 4, so the plus 20 changed to negative. And then I'm going to pull my common factors, y minus 5 to the front. Y squared minus 4 is what I collect. Now I need to notice that y squared minus 4 is a difference of squares. And I need to go one step further. So y minus 2, y plus 2. You try the next one. Same thing, 4 terms should always say to you factor by grouping. When you're finished, you should have p plus 3, p minus 3, p plus 7. If you get stuck, come to the discussion and know how to ask for help. The second special case in here is a perfect square trinomial. So what this means is it looks like this with either a plus or minus. It's a squared plus 2 times whatever a and b are plus b squared. When you factor it, it's the same set of factors, same binomial twice. That's all it is. If this 2ab term is positive, this is a plus. If it's negative, the center is a minus. So let's see what it looks like. Determine if the first and third terms are both perfect squares and have positive coefficients. If that's the case, it might be a perfect square trinomial. If this is the case, identify a and b and determine if the middle term is 2ab or minus 2ab. All right, well, let's try that. So I'm going to look at the first one. X squared is a perfect square, 49 is a perfect square, so it might be a perfect square trinomial. The base of x squared is x. The base of x 49 is 7. It's a and b. So if I do 2 times 7 times x, what do I get? I get 14x. So this is a perfect square. This is a positive 14x, so I'm going to have x plus 7 squared. Or I can write it as x plus 7, x plus 7. Perfect squares can be factored in using the AC test or using the standard way we would go about it. Know that. It would still work here. You'll be able to figure it out. But it's easier if you recognize it. So I'm going to look at the next one. This is a perfect square, 25y squared, as is 4. So they're both positive, could be a perfect square. The base of 25 is y, 5. The base of y squared is y. The base of 4 is 2. So if I do 2 times 5 times y times 2 again, double it, I get 10y times 2 is 20. So it is a perfect square. I know from the minus sign that my binomial is going to have a minus in the middle. So it's going to be 5y minus 2. Okay? Look at the next one. It is x squared plus 6x plus 9. So this is a perfect square. So is the 9. It's an x and a 3. X times 3 is 3x times 2 is 6. So this is a perfect square. It's got a minus in front of the 6x. So I'm going to make this x minus 3 squared. And then let's look at the last one. So I have 81w squared. For sure, that's a perfect square. 16 is a perfect square. 81w squared. So I have a 9, a w, and 4. Well, let's think. 9 times 4 is 36. Times w is 36w. Doubled is 72w. So this is a perfect square. That means the 72 is positive. It's going to be plus. So it's going to be 9w plus 4 squared. All right. Last page of this. You try some of these. Okay? First, always look for common terms. Like in the first one, I see a common term. It's actually C, right? It's more than C, even it's 2C. So start there. So I'm going to take out 2C. I'm going to get 8, I'm not going to get 18 together too. I'm going to get 9C squared minus 24CD plus 16D squared. Now what do you see? What kind of trinomial is this? I see perfect square because this is a perfect square and so is this. 3C, 4D. 3C times 4D is 12D, CD. Double that is 24. So it's going to be a perfect square binomial with a negative. 3C minus 4D squared. All right, look at the next one. What do you see? Can you take out anything common? I see common. I'm going to take out a 5. W squared plus 10, sorry, W plus 9. Okay. Well, W squared is a perfect square. 9 is a perfect square. 1 times 3 doubled definitely doesn't get me 10. But I can factor that just a regular way. It's not a perfect square, but I can multiply to make 9 and add to 10, right? 9 times 1 is 9. 9 plus 1 is 10. So I'm just going to factor it the regular way. W plus 1, W plus 9. So you can't be so focused on what this new thing we're doing is that you lose sight of the rest. You got to use all your tools at once. That's the point here. And the next one, I'm going to take out a common term again. So I see 5z. That leaves me with z squared plus 4 zw plus 4w squared. And then I'm going to think about whether or not this is a perfect square, because that is, and so is 4w squared. So z times 2 times w would be 2zw times 2 again. So this is a perfect square. 5z at the front times z plus, because this is a plus, 2w. That whole thing squared. All right. And then you do the last one. What's the common term? I see a 10, right? I get 4x squared plus 13x plus 9. Okay. Well, let's see. Could be a perfect square. This is perfect. 4x squared, as is 9. So 2x times 3. 2x times 3 is 6. Double is 12, not 13. So it is not a perfect square. It means I can just factor it. I can use the AC test. So go through and try that. So I want to multiply to make 4 times 9 is 36 and add to make 13. Let's see, I could use 9 and 4, right? Okay, so I'm going to split that. Right, 4x squared plus 4x plus 9x plus 9. Not terrible. Group. So I get 10. On the outside, 4x leaves me x plus 1. We'll add a 9. Leaves me x plus 1. And now combine stuff around. So I'm going to get 10 at the front, x plus 1, 4x plus 9. You're going to have to use all the tricks in your bag to do these. So practice, practice, practice. And if you need help, you know where to find me.